Yeah. How many is here? Yeah, everyone else is here. Okay, first and foremost, let's talk about circular motion, guys. Now, in your IGCSEs, whenever they talk about circular motion, right? Whenever they talk about circular motion, it is quite a straightforward question with always a straightforward answer, guys. So in order to understand circular motion, let's imagine today the most common circular motion object, which is basically the Earth and also the Moon, right? Now we know for a fact that the Moon is definitely going to orbit around the Earth, right? Now the reason why it orbits around the Earth like this here is because at this specific instance, there are actually two forces acting on it. One, which is the motion of the Moon, right? And another one, which is towards the center of the circle. What force is this towards the center of the circle, guys? Obviously, it is the gravitational pull, all right, which obviously, guys, you have to always remember gravity is a form of acceleration, guys. And every time there is acceleration, it is due to what? No. Due to what? Wait. Every time there is acceleration is due to what? There is a formula to explain this as well. What? No, resultant force, guys, is a resultant force always, guys, is related to the F equals to ma formula, guys. Anytime there is acceleration in any object is due to a resultant force. Now, in your IGCSEs, right, they love to ask you these kind of questions. So you can definitely expect at least one question from the paper 2 paper to ask you something like this. And the question will always be the same one. It's very standardized one. They'll ask you which direction is the resultant force, which direction is the acceleration, or something along the lines, guys. As soon as you identify that this is circular motion, I want you to know that there is acceleration towards the center of the circle, and because there is acceleration towards the center of the circle, there is resultant force towards the center of the circle, guys. For those who have actually attempted some past year papers, you'll see it's going to be something like this, guys. In conclusion, if you want to cut all the bullshit short, right? Anytime you see anything that's circular motion, right? Circle the one that is pointing towards the center of the circle. 90% of the time you'll get it right. But of course, if you want to make sure that 10% you don't get it wrong, you read the damn question properly, right? Because you don't go into the exam hall and say, oh, my teacher say for sure it's the arrow pointing towards the center. Then you're dumb, right? Read the question, guys. But 90% of the time, the answer is always towards the center of the circle. You must know this. This is like the freest mark of the free marks, guys. It's for sure, most likely, the answer is something like resultant force towards the center of the circle, or acceleration towards the center of the circle, or something along the lines. Or there will be one arrow that lets you pick. They'll pick like in between, like something like this. It's like A, B, C, D. And the answer is always going to be the one that's pointing towards the center of the circle. Okay. It's very important, guys. It's like the freest of the free marks, guys. It's going to be the freest of the free marks. So always remember, anytime there's circular motion, it is because there is a resultant force or acceleration towards the center of the circle. Now, at any given point, because there is two forces, right, what's going to happen is it will always have one resultant force in between the forces. For example, if my Moon is here, there will be one force that's going down, and there will be one force going towards the center of the circle again, which gives you a resultant force here, right? Same thing like this, same thing like this. Here is the resultant force, same thing like this, same thing like this. Here is your resultant force. Very, very important now, guys. You all must know this. Okay. Anyone's got any questions from this part here? Anyone don't understand what I'm talking about? This is free marks, by the way. Everyone must know this.
The resultant force is that.
Yeah, for sure towards the center of the circle. Imagine if, let's say today there's no resultant force towards the center of the circle, right? You know where the Moon will go? It will go directly straight like this, right? And it is because of the resultant force that is in towards the center of the circle. That's why it gives rise to this part here.
Resultant force.
In this case, yes, it's the gravitational pull. It's due to the gravitational pull. So if there's acceleration towards the center of circle, that means there's resultant force. Yes, for sure. And if there is acceleration, there will definitely be resultant force. And actually, to be more specific, the reason why there is acceleration is because there is resultant forces. For those who have forgotten about resultant force is just the extra force acting on an object. For example, if I have 1000 newtons here and 30 newtons here, my resultant force is obviously towards the right lah, right? So whenever we say resultant force, it's just a fancy term to say how much extra force is acting on it. And when we do the F equals to MA calculation, guys, a lot of students, they sometimes they'll substitute this into here or they'll substitute this into here. Let me tell you right now, guys, if any one of you guys dare to do this, I will beat you. For sure, you better not let me see that in your class. This F is always the resultant force, which is supposed to be this thing here, not this, not this. Understand? Very important. Okay. Anyone's got any questions from this part here, guys, before I move on? Anyone online that's got a question? Oh, Shani is here.
So the two arrow is remember.
Huh?
The two arrow.
Yeah, this one here. This one here is the resultant force due to this and this force. Okay. Yeah, it's always in the middle. You don't know how this is related in real life? Let me show you right now, guys. Hey, put your both hands like this. Hey, if we both pull at the same time, right, what you'll notice is that you'll definitely go towards the center, guys, which proves that anytime you have two forces acting on an object, it will always have a resultant force towards the center. Very, very important. You must know this. Okay. Right. Then, yeah. What else do you need to know? Oh, moments. Hey, guys, for some godforsaken reason, godforsaken reason, right? The students are always very confused with the moments chapter. First and foremost, let's talk about moments. So what's a moment again, guys? Okay, that's the formula. Moment is force multiplied by perpendicular distance to the what? To the pivot, guys. Very, very important. It is always towards the pivot. So from here, if your IGCSEs is ever going to ask you to define a moment, guys, I want you to know that a moment is supposed to be a force that causes a turning effect. For example, today if I have a seesaw here, right, and I have someone standing here, what's going to happen is, obviously, this is an example of a moment, right? Why? Because the force will be towards the downwards direction. The distance to the pivot will be in this direction here, guys. I want to highlight one thing, guys, in terms of moment. Moment has the exact same formula as work done. A moment is equals to force times distance. Work done is also supposed to be force times distance. So my question is this, guys. What's the difference between the two of them? Good, excellent. One is perpendicular and one must be parallel to each other. For example, if I have a block on the ground, right, and I push it with a certain force, it moves with a certain distance, then this is going to be work done, right? Right. But for moments, the force and distance must forever be perpendicular to each other. If it's not perpendicular, you are not correct, guys. Don't give me some random distance and then tell me that it's force times distance. It doesn't work that way, guys. It must be perpendicular to each other. Okay. And if they ask you to define, just say that it's a turning effect, a turning effect due to a force of an object or whatever along the lines. Right. Just make sure you say the word turning effect. It causes a turning effect. A turning effect. You have to mention this word. It causes a turning effect due to the force or whatever, something along the lines. Okay, everyone. Now, of course, in IGCSEs, if they only ask about moments, you should thank the heavens above. Most likely, they won't just ask about moments. They will ask about moments in equilibrium. Moments in equilibrium, right? What does moments in equilibrium mean? What's the term for the formula? Total what? Excellent job. It is supposed to be the total anti-clockwise moment is equals to the total clockwise moment. For example, just now this scenario here, what's going to happen is obviously this seesaw is going to tilt in this direction, right? It's going to turn in this direction, right? So in order to counter this effect, we have to exert the exact same moment in this direction, right? So means to say I have to put the exact same guy with the same weight standing the exact same distance in the pivot, in the seesaw, then this will be a moment in equilibrium because the total anti-clockwise moment is equals to the total clockwise moment. This is super important. And in school, I'm pretty sure a lot of teachers, they teach you this. They tell you that F1 D1 is equals to F2 D2, right? Now, this can only be true if there is only two forces acting on the damn seesaw, guys. You know, I've seen a lot of students, it sounds really dumb, right? But I've seen a lot of students, they tell me like this. There's like two forces here, and one more force here, and then they dare give me this as the formula when they do the calculation. Wait, hello, read the question a bit lah, right? So I know the school teacher tells you F1 D1 is equal to F2 D2, but this is clearly three forces, right? If it is three forces, what would the formula be here? Oh my God. Excellent job. It's supposed to be F1 D1 plus F2 D2. Why? Because these two forces will create an anti-clockwise moment, right? And then it's obviously equals to this one now, which is going to be F3 D3 here. Okay, now one more question I want to ask with regards to this. If let's say, right, I say that here to here, yeah, let me design the question and then everyone tell me what the answers are. If let's say I say that this force here is 100 newtons and this is 200 newtons and this is like 300 newtons here, right? And I say that here to here is like maybe for ease of calculation, this is not going to be right, but for ease of calculation, let's say like this is 1 meter and then this is like probably 2 meters, right? And they want you to find this here. They want you to find this here, which is obviously your D3. What should I do when I have all this information? How do I substitute it in? Obviously, my F1 is going to be 100, right? How much is my D1? 1. How many of you guys say 1? Any of these idiots here tell me it's 1? It's not going to be 1. Hey, guys, it sounds dumb, guys. Don't let me ever see you put 1 there. 1 is force 1 to force 2, but the formula is distance to the pivot, guys. Is distance to the pivot, yeah. So it's supposed to be 3, guys. It sounds dumb, right? Then it's 200 times how much? 200. 300 and D3, right? This is supposed to be a formula. If they give you three forces here, guys, think a little bit lah. Don't be a sheeple, right? Don't be sheeple, right? Teacher tell me F1 D1 equals F2 D2. Sheeple, you damn sheeple, you're not people. The sheep, right? Make sure you know this, everyone. Make sure you know this. Very, very important. In fact, later I'll be walking around seeing any one of you guys doing the same mistake I tell you not to do, and I'll give you one good beating for sure. What? Yeah. Okay, anyone's got any questions for this part here? Very important. Always write down the formula. Moments in equilibrium states that the total anti-clockwise moment must be equals to clockwise moment. Oh, by the way, until now, anyone don't know how to find which one is clockwise and which one is anti-clockwise or not? Anyone don't know how to find which one is clockwise or anti-clockwise? Everyone don't raise up their hand, right? Oh, sure. Yeah. Anyone don't have the paper yet? Huh? There you go, fire. Okay, very, very important. Then after that, last thing I want to talk about is basically vectors, guys. Hey guys, in terms of vectors, you know just now how I told you, if I have one object being pulled at 2 directions, usually I'll have a resultant force in between the two forces, right? In your exam, they'll actually ask you to draw the triangles in these kind of scenarios, guys. Anyone here don't know how to draw triangles? Anyone don't know what I'm talking about? Anyone never heard of vectors before? Okay, now pay attention, guys. This is important. A lot of students, they always get very confused with this chapter for some reason. Okay, but the basic concept here is, first and foremost, you need to understand that when there are two forces, there will be a resultant force in the middle here. Okay. Now in your exam, they'll usually give you they'll give you some information along the lines. Let's say for ease of calculation right now, let's say that this thing here is 100 newtons and this thing here is 300 newtons here. Right. And they ask you to find the resultant force, and they ask you to draw the vector as well. How do we begin? What? Yes, you must first identify the scale first. Guys, why is it important to identify the scale? Let's say, for example, in your exam paper, right? This is the question, and this is the empty space that is given to you to draw the scale, right? If you drew the scale wrong, you might have this triangle here, or you might have a super large triangle here, guys. Know for a fact that the triangle scale must at least fit 50% of the empty space, guys. If you drew anything smaller than 50% of the empty space, you better hope and pray everyone is wrong together. If not, most likely, you will lose your marks. Okay. So from here, if let's say we make it simple right now, let's just say I say that 1 cm is equivalent to, I don't know, 50 newtons. This will be my scale that I'm supposed to draw. Once I identify this scale, I'm supposed to make these three forces into a triangle, guys. Looking at this right now, obviously it's not a triangle, right? Looking at this right now is definitely not a triangle, right? What should I do to make it into a triangle? Which one? Good. I should move either the 300 towards the right, or I could move the 100 towards the bottom. If, let's say, I move the 300 towards the right, what's going to happen is I'll still draw the 100 first, and then I'll draw the 300, and this will be my resultant force. Guys, pay attention here. You'll notice that the one that is towards the right will still be towards the right. The one that is supposed to be downwards will still be downwards, and the resultant force will still be in the same direction. You know what a lot of my students will draw? And I'll definitely beat you as well if I see this. Some students, right, they'll draw me like this. They'll draw it like this. Oh, this is triangle, connect. Then connect these two, then this is the triangle already. Guys, you know how dumb this is? If let's say you are one of this person, right, I want to let you know that if you're basically saying, I want to let you know that if let's say you say this is the triangle, right? One force that pulls down here and one force that pulls down here, miraculously, for some God-forsaken reason, makes the guy move in this direction or in this direction. You know how dumb that sounds? It's like A for ball. You know, that kind of scenario. A for ball, you know, B for apple, C for donkey. Guys, you better not let me see you guys do this. Remember, you're not trying just to make a triangle. You're trying to make all the arrows point in the proper direction and form the damn triangle. Okay? Very, very important. If you do not want to move the 300, alternatively, you could move it like this also, guys. You could move the 100 down. So you still draw the 300. You move the 100 down to here, and you'll have your resultant force in this direction. You'll notice that it is still all pointing in the same direction. Down will still be down, right will still be right. The resultant force will still be in that slanted direction. Okay, very good. Very, very good. Okay. So if once you're done with this, right, once you have the whole triangle in your mind, right, the next thing is just drawing it to scale only, right? So if I draw to scale here, this thing will probably be like 2 cm, right? And this thing will probably be like 6 cm. And then once you have these two forces, right, you connect this point to this point here, and you just measure how long this resultant force is. Let's say after you measure, right, you found out that, oh, this resultant force is somewhere around 7 cm. Then your resultant force must be 350 newtons, right? You get what I mean? It's all supposed to follow the scale, guys. Okay. Anyone's got any questions for this part here? If you have no questions, right, everyone flip to the last page here and start doing this question first. I want to walk and see how many of you guys actually don't know how to do this. Hey, for those who are online, do this page first. It's supposed to be the last page of the PDF file that I've sent online, guys. Yes, and for those who do not know where northeast southwest is, it's supposed to be northeast southwest. Okay, everyone, do it now. I'll give you 10 minutes. Draw me something and show me your results. Everyone, draw this page right now.
Miss, do you want to go to where?
Yes.
Most popular one.
I不知道。
你叫我不知道，还有头。
画啊！画！
这样子画。小啊。那我输了，这个是去加的，就来跟两个这个我的。
我的宝座也，我的成绩在这边了。last week 2 days ago， 哦 ，Saturday 的时候，也是一个
那好像是给你到太阳了。哦，拿屁股，那点拿自由，你得把不能和同事对打。啊，是吗？干嘛这个？这个，你冲我，我你下个也，你已经有一些嘛，我在找他。然后好，哦，我给钱呐，我给干嘛呀？教给参加高平的领导来。一样的啊，你要发挥成长点。我就下了。Yes. Wow. Rồi, dòng của tôi
That's a range of the
Looks correct. Looks correct. Looks correct. Oh, yours looks a bit small.
Sorry, what is it? Like two, then like quite big.
No. This one, no, this one you don't draw this one. You like
Only have left this one thing.
so you have to erase it for sure. Direction, 你要转那个 angle.
Angle 啊
Huh? You're supposed to have it. What?
Angle
Southwest side. Yeah. Yes, correct. No, you need this direction of the resultant force. You need to put the angle. Hey, Vicky, this one you got to put the angle. This one. Yeah. Ôi, bây giờ sao về cho anh em nhiều. No, we can only draw one, bro. Yes, you could do that. Okay, sure, man. You have to specify. If you measure the angle from the west one, then you say it's like 30 degrees from the west. Or if you're measuring it from the south one, then you have to measure like how many degrees from the south.
It's a skill. I put it as
1 centimeter is 2 cm.
1 meter is 2 cm.
1 meter is 2 cm.
The skill.
How do 1 meter is 2 cm? Meter and cm are both length. 讲什么零？那里可能 2 cm is equal to 1 meter. This is meters per second, right? First and foremost, this thing here should be 1 cm represents how much? This is in meters per second, right? You 先猜咗啊！呢個 2 cm 邊度嚟嘅？一個1 meter 邊度嚟嘅？你知道我講什麼嗎？ This is in meters per second. You get what I mean? So if you write the scale, it should be like 1 cm ... which means represent how many meters per second in this scenario. 明白嗎？
West side 這個 direction 拜拜，在這邊啊。老師講啊，你剛剛這樣感覺說，告訴我，我買東西啦。
對啊，這個0.5咩？ Don't write 2 cm equals to 1 meter. It's like write 1 cm represents how much? It's 1 cm represents 0.5 here, right? 也对啊。
Gabriel Tan.
6.9 哇，吧。
I mean, sir, the result books I need to count in CM result.
Oh, because you meters per second lah.
Result then.
Meters per second.
Oh, that comes. 对哦，错了。那到吗？能为吗？啊？有有外方看你的啊，这都。你看你这个是我刚刚就对呀，没有，你这个他这个房子从这边来，这边看错了，跟他从这边来，跟他从这边来，他这个朝着对。
Yours is so different. What's the answer? Vicky, what's your answer? 7.4 is it? Why yours is 14? 你的也是不圆的了。114.6 cm 哦，喂，怎么这里除2，这里变成乘2了喂。Okay, everyone, I think you have all attempted the question already by now. Guys, pay attention. Oh my God, where's my mouse? Yeah, looks correct right now. Okay, everyone, sit down, shut up, pay attention.
Okay, Daddy.
Daddy.
Okay, so basically, I think everyone got it correct lah, right? I walked around, I saw no one to beat, or I'm a bit relieved that I didn't need to beat anyone. But anyways, oh my God, why is it so sensitive? What? Anyways, hey guys, this question here, it says, it starts off with west, west, which is in towards the right or left? It's supposed to. Towards the left, all right. And then this one is south, which is obviously towards the downward direction lah. Usually what I like to do is when I see these kind of questions, right, I actually like to draw like a mini map, you know, I'll draw something like this at the side here. Then I know that, oh, okay, this is my final answer. And I'll just draw something like this, either something like this at the bottom, or I'll draw something at the side here, right? Either way is correct. But let's say if I draw something on the side here, I know that if let's say 1 cm is supposed to represent 0.5 meters per second, then this thing here will be how much? 13. This will be 13 cm, and then this one will be 7 cm, right? Then after that, it's just a matter of connecting this part to this part here. Then when you draw, guys, make sure you use at least 50% of the space because it is definitely designed for you to use more than 50% of the space. And from here, yeah, you'll get 7 cm. Make sure you label everything, guys. Don't just draw a triangle like I saw in Nishan's paper. You're supposed to label everything, and then you're supposed to draw the arrows as well, guys. Draw the arrows, label everything, and then say that this thing here is how much? Somewhere around 13 cm, right? Which means to say it should be 15. Sorry, it's 15, somewhere around 15 cm, is it?
14.
Somewhere around there. There's going to be a range of acceptable answers, guys, but let's just say for ease of explanation, this is 15 cm, right? Now, obviously, your resultant velocity is going to be 7.5 meters per second. Your scale is going to represent, guys, you always start off with 1 cm represents blah, blah, blah. You don't try to be funny and go like 2 cm represents blah, 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 or like how many blah, 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 blah. It doesn't work that way. It always starts with 1 cm representing blah, blah, blah. In this case, it will be 0.5 meters per second. And the direction of your resultant force, you're supposed to either measure this angle here or this angle here. If you measure this angle, let's say it's 30 degrees. You're just going to say that it is 30 degrees. You write 30 degrees from the south. Or if you measure this angle here, and let's say this is 40 degrees, right? You're going to say that it's 40 degrees from the west force or the west direction. Okay, this is what you're supposed to write. Guys, anyone unclear? Anyone don't know what I'm talking about? I remember the mark scheme giving it in angles. I don't remember it giving it in a yeah. Of course, it's like common sense, that one you have to know it. Okay. Yeah, you have to know, bro. It's hey for those who are having difficulty remembering north, east, southwest, it starts with the clockwise. Just say it in your head a few times, right? North, east, southwest, or you could remember it in a thunder sign, which I prefer. You know, the word news came from north, east, southwest. It's basically saying information from all around the world. That's why it's called news, you know, right? So you either remember the thunder sign or remember the clockwise north, east, southwest. Yeah.
The news like a real story or like it's made up.
No, it's a real story. I mean, the thunder sign is a made up thing, right? But the news is actually from this north, east, southwest. It basically means information from all around the world. Because that sounds dumb now, obviously. Huh? 我知道这边是东，这边是西。What the fuck？ 西是下面，这个是北，这个是南，好不好 ？What the？ Right, but yeah, if you don't remember the clockwise north, east, southwest, then remember the news as a thunder sign. But you don't be dumb later. You thunder it like this way. Then it's GG. Just remember thunder sign downwards. Thunder sign. Later you thunder sign like this, and you say, "Oh, north, east, southwest." And then they tell me, the teacher tell me the thunder sign. Then it's GG. Then it's a yeah. GG. Then welcome back to GTG lah after your exam. Slanting that or thunder or whatever lah. It doesn't matter. So we remember it. Okay. All right, everyone. Oh, by the way, I haven't checked my answers yet. What's the answer? Yeah, it should be correct one lah. Okay, guys. Please try to attempt the ABC questions. I'm gonna give you guys like probably 15 minutes to attempt everything. Huh? What's 73? Which how do you get 75 meters per second? Oh, it's 7.5. Oh, Sydney. It's 7.5. Sorry. Yeah. Huh? Oh, sorry. Thank you for reminding me. Yeah, it's 7.5 because we're dividing this by half. Finish the whole paper. Enjoy the rest of your time. Just joking. Hey, finish the ABC part away, guys. Then you say it's like how many degrees from the west direction? This is your west direction, right? How many degrees from the south direction? Yeah. Okay, guys, I'm going to mute because the class is getting a bit noisier, but make sure you ask me anything if you have any questions. Hey, sorry, sit down. Hey, orange, sit down. 喂，全部人坐下来。喂，I'll discuss the answers already. Okay, everyone, let's go through the answers real quick, guys. Yeah, let's straight away find the mark. Let's mark your answers, guys, straight away. Yeah, it's this one. Hey, check your answers, everyone. Question number 1. Oh my God, it's not sharing screen. Yeah, question number 1, C. Question number 2, donkey. Question number 3, C. Question number 4, boy. 4, boy. 2, donkey. 5, boy. Everyone pay attention now. I'll say this one last time. Question number 1, C. Question number 2, donkey. Wait, I'll explain. Question number 3, C. Question 4, boy. Question 5, boy. 6, boy. 7, C. 8, A. 9, boy. 10, boy. 11, donkey, and 12, C. Okay, let's go one by one. Which one do you guys want me to talk about? Question number 2. What's this? Hey, how many of you guys got full? Hey, my favorite boy. 你看他，你知道为什么他拿full吗？因为他有来星期六的 class， 他有来星期六的 class， 你知道吗？Oh my God. 8 to 10. 8, 8, 9, boy, 10, boy. Okay, question number 2. Let's go. What's this? A boat is traveling at a steady speed in a... Oh, everyone shut up. Everyone shut up. It's a steady speed in a straight line across the lake. Which statement about the boat is correct? Who was the one that wanted this? Who wrote anything else? Who wrote anything else? You wrote B. The resultant force on the boat is in the opposite direction of its movement. How can the resultant force be in the opposite direction? If there was a resultant force in the opposite direction of its motion, wouldn't it move towards the backwards instead? No. If let's say this is the case, right, it will be decelerating. You know, if B was the case, right, this will be decelerating, not steady speed. Why is it not? The resultant force on the boat is in the direction of the motion. How can there be resultant force? If I have resultant force in the direction of the motion, wouldn't it be accelerating? According to the F equals to ma formula. Right. Wait, I just talked about it just now. F equals to ma, right? This F is always the resultant force. Because of this resultant force, it causes it to accelerate. Right. If let's say you say that A is the answer, resultant force and the boat is in the direction of the motion, then it will accelerate, right? Oh, come on.
The resultant force is vertically downward and going down.
Yeah. Which the resultant force for sure will be 0, guys. In order for the resultant force to be 0, there's only 2 conditions. Either the object is stationary or the object is moving at constant speed. For example, when your parents are driving on the highway and it's, you see the speedometer is 120 kilometers per hour, right? The reason why it's at a steady speed is because the engine is pushing a force and the friction from the ground is the exact same force. That's why it's constant speed. If you want to accelerate, your parents have to step on the pedal, right? When it steps on the pedal, the engine force will be greater than the friction on the ground. Then it will accelerate. Oh, 明白吗?
Yeah.
Okay, which question? Next question. Question 3. I want to explain question 3 a bit. How many of you guys got this correct? Question 3? Wow, not bad. Wow, everyone got it correct. Not bad. Hey, let me emphasize this question again, guys. Whenever there is horizontal forces acting on an object, it will not affect the vertical forces. In this scenario here, it says that the keyword here is that it is moving at terminal velocity. In order for it to move at terminal velocity, which is constant speed, the upward forces must be equals to the downward forces. This is a must. That's what terminal velocity is, right? And then they say there's a gush of wind, right? This horizontal force will have zero effect on the vertical forces. Horizontal forces will have zero effect on the vertical forces, guys. Very, very important. I think a lot of you guys circle A as the answer, right? Yeah. It's a very common mistake, guys. It is definitely not A. Next question. Which other question you guys got it wrong? Question 4. Nani? Why? This one already give you that this is obviously going to be moments in equilibrium, right? So let me ask you guys this: where is this 10,000 newtons acting on? Yeah, at the 2 meter there. What? How does that work? How does that work? F1 dy equals to F2 d2, right? What the hell? This one is clear. Hey guys, a key word to look out of is as soon as you see this word, the pivot, right? For sure, they want to test you on moments, right? No need to question. For sure, it's going to be moments already. So it's going to be force times distance, or it's going to be moments in equilibrium, which is F1 d1 equals to F2 d2. Very, very important keyword. Pivot is a dead giveaway for moments. See the word pivot. Oh, this is a moment question. Moment equals to force times distance. Straight away. Okay. Calculation error for sure. Next question. Question 6. A spring obeys Hooke's law. Oh, I didn't mention this. It is unstretched length of 10 cm. The load of 20 newtons hung on it, and new length is going to be this. What's your extension? Your extension is supposed to be 26, right? Good. And after that, your force is obviously going to be 20 newtons, right? What's the formula for Hooke's law? Oh. So your K is equals to F over X. In this case, here it will be 20 divided by 36, right? Which, I don't know, I think 0.77. Is it me? Yeah. How do you get 1.8, Natalie? Oh, okay, very good. Okay. Yeah. Hey, a lot of students, they always make this mistake also. They see the length and straight away they think about its extension. Extension is how long it extends due to this new load, guys. All right. Next question. Next question, anyone? Question 10. Excellent. This is actually one of my favorite moment questions, guys. Who is this? This is Lian. Oh no. Hey. Okay, anyways. Hey, look at this question, guys. The diagram shows a man holding a sack and barrel stationary, blah, blah, blah. The center of mass of the weight of the sack are shown will acts as a pivot. Yet again, it is the word pivot here. So for sure it's moments, right? If it's for sure moments, then I know, I'm looking at this diagram here, there's two forces, right? So most likely it's going to be moments in equilibrium. Anything more than one force, it's most likely going to be moments in equilibrium. So from here, straight away, I'm going to write anti-clockwise movement. The total anti-clockwise movement equals to the total clockwise movement here, right? So from here, which one is the anti-clockwise movement? Yes, it's going to be here. Why? Because if this was the pivot, right, this will be the force that causes it to spin. If I simplify this diagram into a much easier way to see it, it will look something like this, guys. Nice. This will be the simplified diagram of this question, guys. I want to emphasize that this and this is useless information. Why? Because they are not perpendicular. This 80 is parallel with this force, useless. This 20 is neither parallel nor perpendicular to any of the forces. So it is definitely useless. Right. So from here, it's just F1 D1 equals to F2 D2. Right. Which in this case here will be 200 multiplied by 15 equals to your F multiplied by 45, is it? Why not?
60. Okay.
It's 60. Why? Why is it 60?
And not you.
Damn lah. It's supposed to add it right, guys. It's always distance to the pivot, guys. It's distance to the pivot. Press it to calculator and you'll find your answer here. Okay. Then after that, any other questions about guys? 11, what's this? Oh, what's your answer for 11? A. Okay, your answer is A. This is basically saying these two forces due to this and this will give you a resultant force in this direction here. Wait, hello, A for ball, man. Right. Hey, I tell you what, this is actually very important. You need to understand that this is the resultant force, right? So if this is the resultant force, I know for a fact that A is impossible, B 唔使睇 because it's in this direction, and then C also 唔使睇 already because it's in this direction, right? For sure it's going to be donkey, ma. Namo Jabao. Okay, Namo. Okay. Then question 12. Hey, I'll explain question 12. Question 12 for this one. Damn lah. Okay, everyone pay attention to question 12. This one here, they want you to find which one has the greatest kinetic energy. We all know for a fact that kinetic energy is dependent on velocity, right? It's not the same thing, but yeah, it's half mv squared for a reason, right? So we know that it's definitely dependent on the velocity, right? But how come all these are forces? How do we relate force with velocity? First and foremost, you need to identify which one has the greatest resultant force. This one has a resultant force of 10. This one has a resultant force of 10. This one has a resultant force of 15. And this one has a 0 resultant force. Guys, according to, yet again, the F equals to ma formula, whichever one has the greatest force will have the greatest acceleration. And according to the A equals to V minus U over T formula, whichever one has the greatest velocity will end up with whichever one has the greatest acceleration will end up with the greatest velocity law. This is how you're supposed to relate other formulas all together, guys. This is very, very important. Okay, and from here, obviously, C is the answer. Okay. Marcus, how much do you get out of this 12? 12? Why didn't you raise your hand just now? Oh, you're so tall, so I didn't see your hand. I only saw orange. Yeah, in between for sure. Okay, guys, then the last part here. Hey, I want to mention this again. If they ever ask you to define anything that has a formula, you're supposed to use the few keywords, right? Plus is the sum of, minus is the difference of, then times is supposed to be the product of, and finally divide is equals to per unit of, right? For example, the sum of the anti-clockwise moments, the difference in the velocity, the product of mass and gravity, right? And force per unit area, all these kind of things are where you need to know this. So from here, if they ask me what is meant by the term weight, I know that weight is equals to mg, right? It's going to be the product of mass and gravity. If you want to be a bit more safe in the downwards direction, if you want to write a lot more, you are free to do so, but it's definitely just 1 mark. Okay. Then after that, calculate the weight of the equipment. The formula is obviously W equals to mg, right? So it's just a matter of this W multiplied by this G. Why? 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 Yeah, this is the gravity of the moon, right? Acceleration of free fall is just a fancy term to say gravity to confuse the students, which I see some of you guys have already been confused. It's supposed to be 350 multiplied by 7.5. What's the units? Newton. Guys, I want to say this W equals to mg is the exact same formula as F equals to ma. Newton, kg, meters per second square, meters per second square. They are the same thing, guys. It's just a different meaning. This weight is for sure down. This F equals to ma could be down, up, down, or left, right. Okay. Press it and calculator, find it yourself. Right. Then finally, the last part here, they ask you whether this thing is going to float or sink. Right. Whether, hey, as soon as you see this word float or sink, for sure it's testing you on density, guys, because only more dense objects sink and less dense object float, guys. So from here, they already give you the density, and they give you the mass here, and this is the volume. And obviously, in this case here, if I want to find the density of the balloon, do I take 80 divided by 0.3? 0.08. Yes, it's supposed to be 0.08. Why? Because this is in kgs per meter cube, guys. You can't compare apple and orange, right? You have to go apple and orange. Yeah, orange is the best. Okay, if you press this in the calculator, you're going to get some random number, right? 0.267 kgs per meter cube. And obviously, because this is less than this, the balloon is obviously going to float towards the top line. So your prediction is obviously the balloon floats. Oh my God. And the explanation is because the density is less than the atmosphere. Okay, it's going to be this one. Congratulations, you have graduated from one chapter.
Yeah.
But you're shaking something else already, is it? Shut up, lah. Okay, guys, yeah, that will be it for today, lah. If you have any questions, you are welcome to stay back. If you have no questions, that will be it for today, guys. I'll see you all next week.